ladies and gentlemen, and welcome to another exciting class with Mr. Simplicity. I mean your host for these classes. Being able to determine the highest common factor between two or more variables or numbers will help you factorize easily. Okay, so we're going to be looking at different cases. We'll start with expansion and then we'll go into factorization. Let's dive into the class for today. So we're starting with algebraic expansion. So we're going to look at what expansion. So let's look at the first example. Algebraic expansion usually occurs when two algebraic expressions, usually one in brackets, having more than one term, are multiplied. So whenever you have two terms, a single term, or two terms times two terms, you can expand. So how do we expand? In expanding, you use the outside term to multiply each of the term inside the bracket, which is to say 2 times x plus 2 times 3. So this is how you expand. This step is not really necessary, but just for clarity. So which means what I'm doing directly is 2 times x, 2x, plus 2 times 3, 6. So this is how we expand. And in order for our expansion to be very good, we must understand combination of sign. Okay? If I have minus times minus, that means two negative terms multiplying, it will eventually give me a positive answer. If I have two positive terms multiplying, it will also give me a positive answer. So if the terms are of the same sign, we get the same positive answer. But if we have a negative times a positive, we have a negative answer. We have a positive times a negative, we have a negative answer. Which means when the signs are different, we eventually will end up with a negative answer. Is that okay? So with this understanding, let's look at the next example. So in the second example, we are going to have something like 2x into a plus y. 2x into a plus y. So if we follow the procedure, this is 2x times a, 2ax. So we say 2xa, but alphabetical order is better in your answer presentation. Which means this times this. Then I'll do this times this. 2x times y will give us 2xy. You get it? Let's take the next one quickly. We're having w into 2x minus z. So what would this be? W times 2x will give us 2wx. W times minus z, positive times negative, will be negative. So that will be minus wz. Is that okay? So this is when we have a single term multiplying a group of 10 in a bracket. So now let's look at other case where we have multiple 10, double 10 times double 10 as our fourth example. So in this case, I have a plus b times x minus y. So what do we do in this case? You take a times everything in the bracket, plus b times everything in the bracket. That's how you split it. So the first bracket, each term will multiply everything in this bracket. A times everything plus b times everything. So now we can simplify for that. You can see we have broken it to be like single term outside. So if I want to expand, a times x, ax, a times minus y, minus ay. B times x plus bx, b times minus y, plus minus is negative, minus by. So this is why how we expand when we have multiple terms. All the terms in the first, we go through all the terms in the second. If I want to ignore this step, I just need to know that then we multiply everything. AX, A times minus Y minus AY, B times X, BX, B times minus Y minus BX, which means like this step is not necessary, I can skip it. Okay, just for clarity. So let's look at other examples. So like I said, all the term in the first bracket, each of the term in the first bracket will multiply everything in the second bracket. So with that in mind, this will give me x times ax, x times minus b minus bx, x times c plus. Okay? Then the second term we have to go through the same way. Y squared times a, that's plus ay squared. Y squared times minus by squared. And y squared times c plus cy squared. So this is how we expand. So anytime you are expanding, just know that you are using the terms of the first bracket to multiply the terms of the second bracket. I hope you understand that. So the next thing I want us to look at in this video, as far as expansion is concerned, is difference of two square. Difference of two square can make your expansion very easy whenever you find them. Okay? Whenever you find difference of two square, your expansion becomes extremely easy and fast if you can apply it. So let's see how to do that. So difference of two square says a square minus b square is equal to a minus b times a plus b. Times if I see two terms like this, you can see it contains only two alphabets, A and B. A and B. The difference is the minus and the plus. So with that, anytime I have a situation like this, I just need to square the first minus square the second to get my answer. That's what difference of two squared means. For example, 2x, or let me say 2 minus p times 2 plus p. This is the same thing as 2 square the first minus p square the second. Okay, so I will end up having 2 square is 4 minus p square. Similarly, if I have 2x plus q times 2x minus q, this will become 2x squared minus q squared. 2 because there are two alphabets, two different or like terms forming the single number here. So I have to put them in the bracket. So when squaring, this will be 2 squared for s squared minus q squared. So the 2 will be squared according to the law of indices, 2 squared s squared. Okay? So that's how we got our 4 squared. So this understanding will help us anytime we are doing expansion in algebra. Okay, so let's delve to the next part of the class for today. We said we're going to look at algebraic factorization as well. So let's look at factorization. So let's look at factorization of algebraic expressions. To factorize an algebraic expression, there's one thing you must know. You must know how to find HCF, which is the highest common factor of numbers. Okay? And secondly, you should also know that factorization is the reverse of the expansion. Okay? Let's say, for instance, I'm giving an expansion 2x plus b times, or no, I'm giving 2 times x minus y. If I expand this, I'm going to have 2x minus 2y. So to factorize this 2x minus 2y, I will ask myself, what is the highest common factor here? The highest common factor is the highest number that can divide this and divide this. And if you observe, the highest number that can divide both sides is 2, 2. 2 can divide this, it will cancel itself. 2 can divide this, it will cancel itself. So that number that can divide the two sides, you bring it out. 2. They use it to divide this short itself. 2x divided by 2, x minus 2y divided by 2, y. So you see, we are back to where we started. Okay? So factorization is the reverse of an expansion. So let's go and see how to find HCF. Okay, let's say I'm giving 8, 16 to find the HCF. In finding the HCF, I will need numbers that can divide the 3 terms, starting from the lowest number. 2 can divide what? If 2 divide is 4. If 2 divide is 8. If 2 divide is 6. What else can divide? All of them. 2 again. 2 here, 2, 2 here, 4, 2 here, 3. What can divide again? Nothing. There's no number again that can divide everything you are seeing here. So this will give me the highest common factor. So the highest common factor between 8, 16, and 12 is 4. Okay? But you don't necessarily need to go and do this table. All you need to do, you can observe and say, okay, 2 can divide. What other number can divide all of them? 4. 4 here, 4 here, 4. It will work. Is there any other number? Until you're sure there's no other number, you can always check with your calculator. And if you perfect it, it will be a piece of cake. Okay? One thing you should always have in mind is that in mathematics, perfection is important. You keep doing, you keep solving, and you become better at it. Let's look at another example. So this is an expression. We want to factorize it. How do we achieve that? Okay. So to factorize this, I will ask myself, what is the highest common factor between 2xy and 3x squared z? So if I go by the normal procedure, the number that can divide here, 2, no number can divide, x can divide. X will cancel itself, 2y. X can divide, it will cancel one of the x, remain 3xz. You know, x squared means x times x. So if you divide by x, it will cancel 1 out, remaining only 1. Okay? If you check, nothing can divide again. Nothing is common between the two of them. So the highest common factor here is x. So another way you can see it without using that table is that you look at the two numbers, what is common apart from the constants 2 and 3. 2 and 3 does not have any common factor, so we leave them like that. So you look at the alphabet, x is here, x is here. How many x is here? 1. How many x is here? X times x. That means there are 2. Understand what I mean by 2? So the square tells you how many x is there. If it's cubed, there are 3. Okay? So I have to remove 1s. The lowest occurring is 1 on this side, 2 on this side. So since 1 is on this side, I have to bring out 1 as my highest common factor. So this will become x into, so you cancel 1x from here, remaining 2y. You cancel 1x from here, remaining 1, so this will be plus 3xz. So this is how we factorize. Okay? Let's take another example. So I can have 6ax cubed plus 3a squared x squared to be factorized. Okay, so we start with the number. What can divide the both of them? 3, if you check. 3 divide 6 will give us 2. 3 divide 3 will give us 1, right? So we can pick 3 as one of the 10, the highest common factor. Then we check the alphabet. We have 1A here, we have 2 here. So we'll pick 1A. We have x cubed, that's 3, and we have x squared, that's 2. So we'll pick x squared. The lowest power is what you pick. So now we'll check what is left.
Starting with the numbers. When 3 divides 6, you have 2. A divides A
is gone. X squared divided x cubed remain 1x because square cube, that's 3 minus 2, law of indices. Take the common base, subtract the power. That's what happened. X cubed divided by x squared. Take the common base, subtract the power. So you have just x left.
So then we go to the second term. 3 divided 3, 1.
That one is gone. A divided a square. Cancel out, remain 1. X squared divided a square. Gone. So this is my answer. So this is factorization. I hope it's clear. I really want it to be clear to you as much as possible. But I'm very sure you are not getting it. Please drop a comment in the comment section below. Ask your question and I will respond to it. Okay, let's go on. So we want to go deeper. Okay. So what we want to do, we want to split minus 5 into two numbers and their product will give us 6. So minus 5 can be minus 1, minus 4. This will give me minus 5. It can be minus 2, minus 3. Minus 2 times minus 3, 6. So this is what we need. So you are looking for two numbers that will, their sum will give you this. The way you multiply it to give you this, because this is positive. So when you check, minus 1 minus 4 is minus 5. But when you multiply it to give you 4. Minus 2 minus 3 is minus 5. When you multiply, it gives you 6. So this is what we need. So it means that we cannot bring our expansion x squared minus 5x plus 6 to now be equal to, you just attach x and replace the middle term. Now be x squared minus 2x minus 3x plus 6. So we're going to factorize. Take this term. What is common? X. Because x squared is x times x, 2x x, like we explained earlier. Okay? So x will come out, remaining x here, then remaining 2 here. Do you understand? Then the next thing, this minus 3x plus 6. In factorization of a quadratic expression, the next bracket will always be the same as the first, x minus 2. So what number can multiply this to give you minus 3? Minus 3. Minus 3 times x is minus 3. Minus 3 times minus 2 is 6. Another thing you can still look at is minus 3 is common. When you bring out minus 3, it will remain x. When you bring out minus 3, it will remain minus 2. So at the end of the day, x minus 2 is a common factor. Bring it out. Anytime you have a common factor, you can bring it out. So I bring them out as x minus 2. What is remaining? X minus 3. So this is how we factorize a quadratic expression. I hope you understand what we have done so far. I really want you to understand this. So take your time, look at other examples. If you have any question, any problem, put it in the comment section below. And don't forget to like this video. It's going to be a lot of encouragement. Share it with your colleagues. Let them learn and let them get problem solved. I'm going to stop here for today till I come your way again. I remain Mr. Simplicitee. Have a nice month.